Welcome back, class, and this isn't your usual video. So I've gone over a lot of the guide on my own, the SAT video guide, which I'm doing right now. So I went over the SAT guide, the book itself, and there are a lot of problems that involve the Pythagorean theorem. So today we will be proving the Pythagorean theorem. So if you're not familiar with this term yet, it's a theorem used to describe the lengths of a triangle's legs and their hypotenuse and the relationship between them. So this was first coined, the term was coined by the mathematician and the philosopher Pythagoras somewhere around 580 to 500 BC. And although there has been proof that the Pythagorean theorem has been used in the years 1000 BC or even further, nobody coined it at that time as the Pythagorean theorem, which is the reason why we consider Pythagoras to have invented the Pythagorean theorem. So what the wording of the theorem is that the squares of the legs of a triangle are the sum of the squares of the legs of a triangle are equal to the squares of the hypotenuse. Now, we can prove this pretty easily down here. Let me draw another triangle, another small triangle. So let's make this a typical 3, 4, 5 triangle. And actually, let's write it a bit more inside here. 3, 4, 5 triangle. So what it means by the sum of the squares of the legs is basically, you can call this side A, this side B, and the hypotenuse C. So A squared plus B squared will be equal to C squared. So we can prove this by drawing out the squares. What we can do is that we can draw this square of length 3 from one leg of the triangle with these lengths of 3. We can draw a square of length 4 over here, although it looks a little bit like a rectangle, but you know what I'm trying to get at. And finally, we draw a square of length 5 over here. Now, the area of this red square will be 9. The area of the blue square will be 16. And the area of the green square will be 25. So it all matches up. 9 plus 16 is equal to 25. Now, if we go a little bit further into this, for instance, let's draw the 5 square square. So with length of 5. And let's grid this square. So 5 columns and 5 rows. Okay. So now we can fit in this red square and this blue square into this green square, even though they won't be completely intact. But if we were to grid those small squares, they could fit in here. So the square of 4, so there's 1, 2, 3, 4, and then 1, 2, 3, 4. 4, 4. That's 4 times 4, 16. The area over here is 16. And then there's the red area of 9, and that's also going to work. So there's 1 square, 2, 3, 4, 5, which is this corner, 6, 7, 8, 9. So there you have the area of 9. So you could see that it definitely works. So there are also these numbers that the Pythagorean theorem has associated with, which are called Pythagorean triples. Let's use a different color. Pythagorean triples. Triples are basically numbers that will always work with the Pythagorean theorem. They're rational numbers, and this will be a very important concept in the Pythagorean theorem. So numbers like 3, 4, 5, which I've already shown you, then numbers like 5, 12, 13, and many more. You can sit and find them out all on your own. And I will be doing another video on the triples because it's another separate topic on its own. But for now, we're just going to stick with this. Then, again, there are also the multiples. So, like 6, 8, 10, or 10, 24, 26. Those also work. So now, I was talking about the Pythagorean triples and irrational numbers. Why irrational numbers won't work. So one day, our little Pythagoras guy over here, he was thinking that, well, what happens if you make a triangle like such with a length of 1? Then what is this going to be equal to? Well, it couldn't have been a whole number or a rational number because that would make no sense. Because 1 squared plus 1 squared, which is just 2, because 1 plus 1. And if you take the square root of 2, that's not a rational number. So during his time, there was no such thing as irrational numbers. So what he did, and his religion, since he was a philosopher himself, which was called Pythagoreanism, it was kind of a secret one. So they never revealed the existence of square root 2 or irrational numbers. It's said that even one guy who tried to tell it to everybody outside, so this irrational is true, when he tried to say it outside, there's rumors that Pythagorean even drowned him or killed him or banished him to outside of Greece where he was from. So the reason why he didn't want to acknowledge this is that it was too broad a concept, basically. Nobody had ever heard of irrational numbers like 0.33 bar, because the decimals would keep on going on and on and on and on until infinity, and it would never stop. So there basically wasn't that good an idea of decimals to work. Now that's a very interesting topic. And if you want to know more, stay tuned in the Pythagorean Theorem series. I will be seeing you in the next video. And one thing I forgot to do is put the icon. It's a sideways icon. I'll see you in the next video. Take care.